Good day, Jeff and Andy. We hope this presentation finds you well and in good spirits. My name is Vic Sheverda.
I'm Jeff Snell.
This is Aaron Urich.
And this is Derek Purshouse.
And we will be sharing our final presentation. Our company is committed to a program aimed at reducing injuries and accidents to an absolute minimum. The success of our safety program depends upon full participation of every member of the team. Each worker has the right to work in a safe and healthy work environment. We deem the legal requirements imposed by government and state jurisdictions to be a minimum standard to achieve and strive for. We take safety seriously, and it is our responsibility to keep each other and the public safe on our jobs. Nothing is more important. We will encourage all of our employees to voice any safety concerns they see on site. We believe it is vital that all employees embody a sense of responsibility when on site and see any unsafe action. Next slide. Next slide. Throughout the length of the westbound on I-76, Castle Rock Construction has identified key features to implement into the safety plan regarding the excavation, haul, and shoring. All personnel involved with the excavation shall have appropriate safety training and complete any requirements in safety training. Retraining will be required in instances when work does not meet certain inspections or when an employee indicates unsafe work conditions. All permits, pre-work inspections will be conducted prior to the excavation. Barricades, walkways, lighting, and fencing shall be provided as necessary protection to the public prior to the start of excavation operations. Next slide. Next slide. All formwork, equipment, and materials shall be inspected on a regular basis for damage or excessive wear to prevent failures, damage, and incidents. Equipment found to be in faulty condition shall be replaced immediately and decommissioned. Forming layouts shall be performed and approved by a qualified and competent individual responsible for the scope of work who understands loading and stresses induced during construction process. Forming installations and pouring procedures shall comply with local and private organization governments. Next slide is paving. Traffic control plans for the movement of vehicles areas so that drivers are also workers conducting tasks. Drivers, workers on foot, and pedestrians must be able to see and understand the routes they are to follow. Overexhaustion and heat-related illness increases during summer heat, especially with the constant heat from the asphalt. Inform supervisor in case you feel fatigued, dizzy, or nauseated. Avoid being in the path of equipment, as there are many struck-by instances and blind spots near and around paving equipment and dump trucks.
And as far as the traffic control goes for the project, the keys here were to follow the CDOT standard traffic control for highway construction or the manual for uniform traffic control devices. In doing so, things that had to be taken into place were the distances between signage and the different traffic control devices to, safely alert everybody that's taking the road, as well as not confuse them in the process of doing so. Something else to take into account with this was the taper length and the sizing of how you got the tapers for the cones and how you would merge the traffic into each lane in a safe manner. Another challenge for this was the construction zone, and in that you had to also take into account how you're going to keep traffic moving either one way or the other, but also to where you keep the workers safe that are on the job site. Overall, the traffic control plan demonstrates how you can safely get through any kind of construction that is going on at the time. Next slide.
So for underground and this scope of work, we provided a risk assessment plan, which rates things from 1 to 5 in order to calculate a risk matrix. so that we can identify hazards that can happen to workers. Underground tends to be one of the most dangerous places on a construction site due to trench cave-ins, falling in, vehicles running too close to trenches. We also added a schedule on there so that we could rate how long it's going to take to complete the job. Sorry, 1 second, guys. Sorry, someone just came in with the speaker. Is there any way we could record that over? I'm so sorry, guys.
Just continue.
Okay. We also had a resource requirement list so that we could know the materials, labor crew, and equipment we're going to need for the job site and be prepared for it. And quantity takeoff for piping, inlets, and the amount of excavation needed, along with backfill materials. Next slide.
Yes, the earthwork on the westbound on-ramp is fill from station 105 through 130, which consisted of 5,643 cubic yards. The superintendent has chosen to get that fill from borrow pit number 1 because of its proximity to the I-76 State Highway 52 interchange. The cut from stations 102 through 124 will serve as both pavement, and the remaining 200 cubic yards will contribute to the required backfill. We selected one Cat 345 excavator to be positioned at the borrow pit to side load 13 belly dump trucks, which will deposit the fill at the embankment. Following the deposit, we will utilize one grader on site to spread out the fill on the embankment in approximately 8-inch lifts in accordance with the specific elevations denoted in the cross sections. There will be 2 compactors that will proceed to densify each lift using 2 passes until the specified elevation is reached with the maximum density tested and approved. We estimate the entire process on site will have 2 crews consisting of 1 superintendent and 2 field engineers supervising for safety and quality control and assurance in accordance with the plans and specs.
Yeah, and as far as the MSC wall structures would go, there's a few key points here, which was, of course, to start identifying the risks that may be involved with the lifting and placing of the panels into the place like that. So identifying the risk was the start, and then the quality control plan was also another key component of what we had to do, whether it dealt with the backfill, concrete strength, and the things like the correct reinforcing straps and things of that nature were also important to consider before starting jobs like this.
For the quality takeoff of the backfill, we worked station by station, measuring from the footing elevation to the top elevation to calculate the square footage of the surface. We then used that number and the back amount to be able to figure out how many cubic yards of backfill were going to be excavated and replaced. We then calculate out the amount of straps needed per panel on each section to be able to get a good estimate on build time and resources needed on site. And yes, next slide.
Yeah, on this slide, we'll be going over the structures. This portion of the WP is focusing on the Pier 2, abutments 1 and 2, and the deck for construction to widen this section of the bridge. You can see on this slide the quantity takeoff used to determine the linear feet of H-piles and the volume of concrete to fill the drilled shafts. You can see here a layout of the EFCO column formworks we used for the columns. You can also see where we'll be using the bridge overhang support system while we pour concrete for the deck. You can also see the DOCA X-Life formwork we'll be using to form up the abutment's wing walls. The sequence we constructed for this will be as follows. For Pier 2, we're We're going to excavate the drill shafts, set the H-piles, pour the concrete. Then we'll form up the formwork for the foot for them, install the column formwork, install the rebar cages. We'll be then pouring the concrete for the columns, installing the bent cap, pour the concrete for the bent cap, and setting the girder beams. For abutments 1 and 2, it'll be very similar. We're going to excavate the drill shafts, set the H-piles, pour the concrete for the drill shafts, form up the work for the abutment walls, install the reinforcement, pour the concrete, set the formwork for the bent cap, pour the bent cap. We're going to be setting the girder beams. Then we'll be doing the formwork for the approach slab, installing the reinforcement for that, and pouring it, and then we'll backfill in. For the bridge deck and the guardrails, we're going to place the deck forms on the girders, install the overhang forms, pour the concrete, and set the formwork for the guardrails, and then pour the guardrails. And that will be next.
And then, yeah, to start with the paving as far as asphalt goes, there was, of course, we developed a safety plan as far as the guidelines that had to be followed. And then moving up based off that with our quantity takeoff, this was based on, measurements that needed to be taken as far as what in the site needed to be replaced with the concrete later on. And so there was the base that we had to account for, and then the 2 different types of asphalt fill that we had to calculate out.
Here on our left, looking at the slide plan for roundabout number 2. You can see here the quantity takeoff we used to calculate the wire line, tie bars, longitudinal steel, and the volume of concrete necessary to complete the job. You can also see the pull plan or sequencing of the pours. Each pull was designed in sequence to allow limited but continuous use of the roundabout while in different stages of the construction. A typical pull sequence would proceed as such. We will deliver have the tie rebar delivered, clean up the area to be paved. We will set the grade using the wire line, establish the truck access, set up the unloader and placer, do a dry run with the paver, concrete pave with the wheeled end dumps, machine float and hand finish the concrete, apply the cure mixture, and it'll take a 7-day cure time. We will then have we will drill and epoxy some tie bars, and then finally we will saw cut the joints necessary. So yeah, we just want to thank you guys for your time today, and we look forward to hearing back from you. Stop the recording.